Hello, welcome to Sutton Grammar. This is the Poseidon Project.
Yeah, we've just finished our first successful test run of our ROV, and it's all looking good so far.
So we've been working with maritime company Subsea 7, who have an office here in Sutton. We're also based in Aberdeen.
We hope you enjoy the following video, which should exhibit some of the activities that have taken place during the project.
Okay, so my main part was the camera system, so using a Raspberry Pi computer to stream HD video from on board the ROV to the surface, so we'd get a first-person view of what the ROV was seeing. One of the challenges we had was latency of inputs and video output, so there's a bit of a time delay sending signals down the tether and bringing them back up, but I think we've managed to reduce that now. So communication is a big skill that we've all developed, just from using our email group to keep in touch with latest developments, sharing files on our shared network storage, and keeping everyone up to date with what was going on.
Well, a lot of the time, students don't really get the chance to express their creativity and science ability in school, because they're always doing more academic work and more concentrating on that. But stuff like this, like ROV, gives you a chance to show what you can do and actually enjoy what you're doing a lot more and feel kind of obliged to come and do your work on the ROV. Firstly, I made a prototype with small little motors you'd find on a small fan with a chip which allowed me to change the polarity of it. And then I pretty much scaled it up with a bigger chip and a bigger motor like we have now. And I simply just designed a PCB based on the datasheet of the chip and connected that to something which allows you to control it with a PS3 controller by an Arduino board.
So the ROV has many applications. The first major one of this is scanning shipwrecks. So the recovery of valuable items from shipwrecks and also the salvaging of valuable parts of the ship itself. Also, it can be used for recreational cave divers or sea divers, so they can help scout out locations before the diver actually has to go down, and it's a lot safer and a lot cheaper than losing someone. They're also used heavily in offshore industry, such as recovery of gas and oil, and also the cleanup if there's an accident because of the oil. There's also marine conservation applications, so the surveying of valuable ocean environments such as the coral reefs. Without putting a human there, it means that there's less damage to the reefs, and also it means you can access areas which aren't necessarily accessible to human divers. So the robot arm is something that I've designed. It started out as something that we bought in, like a pre-made system, and then I've designed my own one, which is waterproof and uses waterproof servos and has got more degrees of freedom. So that means we can move it around, get into smaller spaces and do more things with the objects that we're interacting with. This is just a prototype. We're going to move on hopefully and create a pneumatic system which is more robust and lighter and cheaper as well.
So my role is the Chief Executive of the project, and I'm responsible for ensuring that the project is coordinated efficiently and well. Everyone knows what they're doing, and I think that's quite important for such a long-term project as this is. The managing involves the use of stuff like the Google Drive, in which people are assigned individual roles. There's a timeline on the drive in which people can look up, they can update the activities that they've completed so far. We've had lots of deadlines throughout the year, so people know exactly what they're working towards. I think these are all important little steps to get to where we are at the moment. The external relations have been established through communication with local press agencies. We've contacted the local newspaper. We have also sent off letters to leading institutions within marine engineering, such as Subsea 7, who are quite prominent within the engineering specialist side of the field, but also through the Royal Academy of Engineering. We contacted the president to let him know about the project. The local MP, Paul Burstow, was quite keen on the success of the project and invited us to Parliament to present it to him. So all these little things ensure that there is a captivated audience for the vehicle.
Members of the project have developed many technical skills, including programming in the language of C on Arduino, integration of an RC network in the motor operation system, and the inclusion of RS485 serial communication. We have also used advanced software on a laser cutter for vehicle construction.
We greatly appreciate the advice that we've been given by Subsea 7. They've been quite proactive. We've gone up there for several meetings in which they've highlighted some technical challenges that we may have overseen. So from that perspective, it's been quite useful. On the financial side of things, we were very, very happy to receive the cheque from the worshipful company of Shipwrights, who gave us £1,000 to develop the project so we could buy some more materials that were essential to the evolution of the vehicle. One final mention should also go to Cambridge Circuits, who we were very thankful for providing some of the circuit boards that we need for the electronic side of the project.